You know the rule for derivative, okay? Derivative means I will take the power, bring it down, the exponent, bring it down to the coefficient, and then take that power or the exponent minus 1. So let's quickly review that. Over here, y prime. It's important you recognize the notation because you have to look at what I'm giving to you. I'm giving you to you the derivative. You go backward or just the original function and go and take the derivative. So this one, I'm taking the 3 down. And then 3 minus 2 give me 2. I'm sorry, 3 minus 1. And then the 2, it's just a constant, will be disappear. So my derivative is 3x squared. Okay, so I think that's most of you did that one well. 1 and 2, you do okay. The only thing that you missed was the one thing that you missed is number 3 for some of you. Okay, so if you want to fix it, go back to Kudo Work and fix it, because when I end this lesson, you should be able to save your notes. So f prime, this one, 2, bring it down, so I have 4x. The 5 disappear. G prime is 0 because this is a constant. It's the same at the negative 2 and plus 5 for the other problem. Number 4, I think you did okay. You know what to do, but some of you forgot to bring down the negative. So this is negative 5x. Be careful when you minus 1, it's not going to give you negative 4. I see some of you, 1 or 2 of you was like negative 4 because it's 1 less. But this one is negative 1 less means the number is actually bigger, so be careful with that. So I'll bring this down, so negative 5 over x to the 6. So that's derivative, okay? So if you feel like this is something I need to review, I have not been in class, I have not been paying attention, I didn't do well for my last summative, talk to me, all right? So I know this is a week that is called post-progress. I'm not going to do anything new and extra for you because I've been giving you extended due date on almost every single problem. You have your summative, you can retake, you can do office hour, you want to improve your grades, I've been giving you that opportunity. So the same thing this week, nothing special. I'm not doing anything special, but you want to improve your grades, just talk to me. Office hour every day, 12:45. Okay. I'll share the link again for those who just joined. Go ahead and click on the link. So this is a unit that we're going to talk about is integration. Integrations means we go in backward. So the integral, I'm going to highlight this one. This notation right here, this curve is the integration, the integral, the one that I highlight is called the integral. When you see this, it will tell you this one is antiderivative. We go in backward. Okay, so that the one that I highlight is called the integrals. That's curve, right? So when you see this one, the one that you see on the example, 3x is actually the derivative. That's why you see the word right here, dx. That means it's derivative of x values, dx. In here, it's telling you this is the derivative, okay? So when you see this, they're asking you to find the integral. That means you're going to go backward. You're going to find the original function that's given to you. Okay, so let's go back, look at the few rules that we're going to look at. For the one that we're going to do, I want you to focus on this one, this rule right here, number 6. Okay, it's the power rule. Remember when you take the derivative, let's review a little bit. If I have this function y equal x to the 3rd, to take the derivative, right, I bring down the 3, and then the exponent, I will minus 1. If I have a number, that number just disappears, so I don't have anything. So in here, it's going to be 3x squared. So now, with the integration means this is what given to you, the 3x squared, dx. This is in derivative. They want you to go backward to the original function. So the rule is, remember when you took the derivative, you're gonna minus 1. But if you're going to do antiderivative instead of minus 1, look at the rule number 6. We're going to add 1 because we want to go backward, right? And here to get to the derivative, I'm minus 1. Now I got the derivative, I want to go back. So I'm reverse the order. So I'm going to add 1 instead. So look over here. I'm going to add 1 and then divide, which at whatever the number, the power that n plus 1, I'm going to divide by that. And then the c over here plus c, it's just count for the constant that we don't know. For example, for this one, if I look at x to the third plus 3, my derivative is going to be 3x squared. If I have another function, x to the third plus 5, my derivative is still the same thing because the 5 just disappears. So I don't know what that is. So the c is there to cover for the constant that was disappear. Okay, so that's what we're going to look at for today. We go backward. So this is the rule that you want to focus. We're going to go backward. It's going to be n plus 1 instead of n minus 1. And then remember how we multiply the n, the exponent? Now we're going to divide that. So it's the opposite. We do in reverse order. And one thing you want to pay attention to is a plus c. Okay? So I'm going to do this example. This is 3x. There's nothing is the same as 1 to the power of 1. So here's the rule that I'm going to do. So 3x, you see the power is 1, right? I'm going backwards, so it's going to be plus 1. Divide. When I divide, like I said, I will divide for that new exponent that I just add. So 1 plus 1. And then I make sure that I do the plus c because I don't know if that function have a constant or not. So that's going to be plus c. So the antiderivative of the integration would be 3x squared over 2 plus c. Okay, I know this is new and sound like that's a lot of steps. It's not. We're going to do practice. We're going to spend today and next day to practice on this. So right now, question for me in the steps. Step number 1, I would add the exponent by 1. Step number 2, I will divide by that new exponent and then plus c. Questions for me? We'll do more example, of course. Okay, let's do for this one. 1 over x to the third. I just have to rewrite this because this one going to turn into negative 3. Okay, the dx saying this is the derivative. Okay, so here's the rule. X, right, negative 3. What do I do with that negative 3? What do I do with that exponent when I'm taking the antiderivative? What is the first step for antiderivative? Step number 1. What do I do with the exponent? Plus 1, yes. So I will plus 1, right? Whatever that I plus, look at my exponent. That is the one that I'm going to divide by. So I'm going to divide, So I'm going to divide by that negative 3 plus 1. And then I would do plus c. Don't forget the plus c. Okay, so now I'm just, as a matter of me, simplify this one. So I'm going to write, I don't have enough space. So I'm going to write over here. So negative 3 plus 1 give me negative 2. Divide by negative 2 plus c. Okay, now we're going to bring down the negative. So I'm just going to bring down this equal. If I bring it down, that's nothing on the numerator. So negative 2 x second power plus c. So you're going to plus 1. You're going to divide that new exponent. and do the plus C. So this one right here, this piece right here is a calculus piece. And most of you, like, I understand the calculus piece. The part that you really struggle is a simplifying part, which is that's a pre-calc, that's an algebra 2 skill that some of you got confused with that. So like I've been telling you, calculus piece, it's not too bad. But if your algebra skill and pre-calc skill is not strong, then that is the part that you struggle with. Because I feel like a lot of you like, what do I do now? Like you understand the calculus piece, but then like I forgot how to factor, I forgot how to simplify, I forgot how to rewrite this function. So if that's the case, check in with me, okay? And let me know. So question for me in the first two examples here. Some of you asked me for flip remote on Wednesday. I don't have office hour this Wednesday, but I have office hour for any other day this week except Wednesday. I have doctor appointment and I won't be in class on Wednesday. So for those who come in a bit late, I won't be in class this Wednesday, but I will record a lesson for you to watch and then practice for you to do. Okay? So it's the same like right now, but instead of me talking directly to you, you have a video to watch with a sample and then you do practice. Okay? So if you need to see me for flip remote, any days this week except Wednesday. So I apologize for that. The derivative, we are not taking derivative. This one we go in for one of you. So are we taking the derivative at the end? No, for this one we're going backward. We go anti-derivative. So we're going backward to original function. So that's why we do the plus C, because I don't know if the function have a constant or not. Okay. All right. If you just joined, there's a link for you to click on. Okay. All right. Let's do another practice, another example. Okay. So even though I have two of these numbers, it's okay. We're going to do one by one, okay? So I'm going to list out the steps. Step number 1, plus 1 for the exponent or the power. That's step number 1, okay? So over here, when I do this, my exponent is 4, so I'm going to plus 1. This one is the same thing. I'm going to plus 1, okay? That's step number 1. I'm going to do an exponent. Step number 2, I'm going to divide by n plus 1, which just means the exponent is plus 1, so I'm going to divide, okay, 4 plus 1, top up here is 3 plus 1. Step number 3, plus c. So I will do a plus c here. So that's the 3 steps for you to do antiderivative. Step number 1, I'm looking at the power, plus 1 to the power. Step number 2, that n plus 1 I will divide for each term. Step number 3, I will do a plus c. And the very last step is simplify everything. So this step right here, step 4, we're going to simplify the function. Okay, so 5x to the 5th power divided by 5 plus 8x to the 4th power divided by 4 plus c. Well, I can simplify again because the 5 cancel out. So x to the 5th, 8 over 4 the same as 2, and then the plus c. Notice I do not divide anything with c. C is just plus c. There's nothing for you to divide, nothing to do with it. The c is in counter for the constant that you may have. You may or may not have. You just don't know. Okay? So question for me, I want you to write out the steps so that it helps you to, when you do the practice, like, what do I do first? What do I do next? Am I following the right order? Okay, so write that down. Take a few second, jot this down, or you need to copy in Pear Deck to do so. I'll give you a few seconds to do it. So if I got this one, okay. So step number 1, what do I do? Step 1, can someone tell me? So I'm doing antiderivative. What is step number 1? Add 1 to the exponent. Thank you. Okay. So for this exponent is 3, so I'm going to do plus 1. This is 2 plus 1. So add 1 to the exponent. Good. Step number 2, what do I do? After I add 1 to the exponent, what do I do? Okay, divide. We're going to divide by, thank you, Elena. So I'm going to divide by n plus 1. Whoops. I should not write n plus 1. In this case, my n plus 1 is 3 plus 1. This one is 2 plus 1. All right, cool. Steps 3. Thank you, Justin. Step 3 is plus c. Thank you, Rudy. So I'm going to plus c. Okay. And then step number 4, this is the one that some of us maybe struggle, is I'm going to have to simplify. Okay, so now I'm just finished up. So this part right here, the plus and divide, that is the calculus part. That is the rule, that is calculus. Now everything else is just algebra 2 skill. Okay, so negative 4 x to the 4th power over 4 plus 9x to the 3rd over 3 plus c. Yes, Justin, we're going to cancel. You should be able to cancel out some of the number for the fraction. We should be able to cancel out. So negative 4 over 4, that's cancel out. So negative 1 x to the 4th power. Okay. 9 divided by 3 is 3 x to the 3rd, and then plus c. So this is the antiderivative. So there are 4 steps for you to do this. You're going to plus 1 and divide that new exponent. Step 3, I'm going to plus c to that function. And then I just simplify everything. Okay? All right, I'll give you a few seconds for you to copy this down and then ask questions. So step number 1, I will add 1. So the exponent plus 1, the 3 plus 1. For the third term, the 10x, the x, if you don't have any exponent, is the same as x to the 1st power, right? So I do 1 plus 1, and then I will divide by that. So now I'm going to simplify. So 6 x to the 6 divided by 6. 4 x to the 4th power divided by 4. 10 x to the 2nd power divided by 2 plus c. Okay, so now I'm going to simplify my function. 6 divided by 6 cancel out. X to the 6, the 4 cancel out. 10 divided by 2, that gave me 5x squared plus c. So the antiderivative of this function is x to the 6 plus x to the 4th power plus 5x squared plus c. Question for me in this one. The one who started it did okay. Some of you haven't started and you seem to be okay for the first steps. Some of you, I noticed the mistake was you still have the integral, that curve. No, don't write that curve, because as soon as you start adding the exponent, that curve is disappear. Okay, so here's the thing. If you're gonna count for the function given 1, 2, whoops, I don't want that color. You have 1, 2, 3 terms. When you do the antiderivative, you're gonna have 4. So it's always 1 more, right? The exponent is gonna be 1 more bigger. So questions for this one. Okay, the plus c. Okay, not too bad. All right, I'm going to clear this one because some of you was like, Miss Wen, why we do the plus c? Because you came in a bit late and you're not sure why it's a plus c. So here's the thing. This is the reason why we have that plus c. For example, if I have this function, 3x to the third plus 4, y equals 3x to the third, y equals 3x to the third plus 5, y equals 3x to the third minus 100. Think about these 4 different functions. If I'm going to take the derivative, okay, it's going to be y prime, right? The 3 bring it over, so 9x squared. The 4 going to be disappear. So that's what I have for the first function. If I'm going to take the derivative for the second one, y prime, it's just going to be 9x squared. If I'm going to take the derivative of the third one, it's just going to be 9x squared because the 5 just disappear. Then if you think about the last one, y prime, it's still going to be 9x squared because the 100 is gone. So that plus c to encounter, if you notice, look at the derivative. Everything is 9x squared. But are they all the same function? No, right? Some of them have a plus 4, some of them have a plus 5, and then negative 100. So that c may or may not be there. We don't know. That's why we do the plus c to indicate there may be a c value, there may be a constant, there may be not. We don't know, but we want to put it there to say it could be a number, it could not be a number. It doesn't matter, but it's there, okay? So that's the plus c for, because we don't know what that constant is. We don't have enough time this quarter for me to go to like do more with the integration. But for now, we just encountered that as the c. Okay, and then on Wednesday, we're going to figure out what that c is. Okay. All right. So no question. This isn't too hard. All right. So for right now, here's the option. If for some of you like, Miss Wen, I need to see more example, then I will do more example with you. Stay in Zoom and do the work and follow along and take notes. But he was like, Miss Wen, I'm good. I'm ready to do practice. Then I'm going to ask you to go to KudoWorks. All right. Go to KudoWorks. And start. Let's not start yet because I have one more thing for you to do. No, I'm going to skip this one. Okay. We're not going to do those, but we had a summary of last week. Yes. So one more thing that I'm going to cover. You was absent, flip remote. See me doing flip remote today or tomorrow or Thursday and Friday. We'll make it up. Okay, one last thing I'm going to cover for the day is the trig function. Okay. So for this one, all right, the antiderivative of cosine, anyone would like to guess? Remember, the derivative of cosine is what? The derivative of sine is what? Now we're going backward. Okay, so cosine, antiderivative of cosine is, can anyone would like to guess what that is? If we go backward? No? So antiderivative of cosine is sine. Remember, when you take the derivative of sine, it gives you cosine. So now antiderivative of cosine is sine, right? Make sure we do the plus c. Okay. Antiderivative of sine is negative cosine, but make sure it's the plus c. So that's a trig function. Remember, we took the derivative with trig function. Now we go backward. So these are the two that you need to have it memorized. So write it down somewhere so you have it. So when you do this, think about sine. The 2, I'm not going to worry about the 2. I will rewrite that. So antiderivative of sine is negative cosine. So negative cosine. Don't forget the plus c. So negative 2 cosine plus c. For here, the 3 over 5 is just a coefficient. Antiderivative of cosine is just sine plus c. So let's see. So it's the same thing, but this time sine is, yeah. Because remember, the derivative of cosine gives you negative sine. So now, because this one is positive sine, so the antiderivative will be negative cosine. Yes. We go backward. Okay, so for this one, it's just 3 over 5 sine plus c. Okay. All right, the last one, the 1 turned into 1x minus 6. Derivative, antiderivative of cosine, it's just sine. Don't forget the plus c. I don't have enough space over here, so I'm going to rewrite this. This can be 1x minus minus 6 sine plus c. Okay, for the 1, it turned into 1x. Because remember when you took the derivative of 1x, the slope is 1. Now we're going backward. We just add the x to it. So if you just have a constant, just add the x to it. So you just have like 5. The antiderivative is going to be 5x. If you just have negative 9, the antiderivative is going to be 9x. So just add the x to it, and that should work. All right, there's the CUDA work assignment for you to work on. I know we have about 7 minutes. That should be enough for some of you. For some of you, it's like, no, it's not enough. Then you finish that homework. But go to CUDA Works, and you may begin that practice. If you like, I'm ready, I know what to do. If you need further example for trig function, I'm going to do a few more examples for you. Okay, so stay in Zoom. Stay in Zoom if you need more example. If you was like, no, I am good, then go ahead and do practice and CUDA Works. And then ask me a question, I can help you. Okay? All right, let's get started.